Presentation on stock trading bot using Q-learning algorithm. And here are a group of people who did this project, that is myself, Yashaswini, Aditya, and Sushanth. And if we go to the introduction of this part, firstly, the stock trading bots, also known as algorithm trading bots, are computer programs that automate the execution of trade and financial markets. These bots utilize predefined rules and algorithm to determine when to buy, sell, or hold stocks and other financial instruments by analyzing real-time market data, historical price patterns, and technical indicators. These bots make informed trading decisions. The use of trading bots offers several advantages over manual trading, including fast trade execution, elimination of human emotions, and the ability to monitor multiple markets simultaneously. And additionally, these trading bots can backtest strategy and on historical data, allowing traders to evaluate performance and make necessary adjustments. And if we come to the other slide, machine learning and artificial intelligence techniques have been increasingly popular in the development of stock trading these days, and these techniques enable bots to like learn from market data, improve decision making, and enhance this trading performance. And some common applications include like supervised learning, where bots are used on like these trading historic data to predict future price movements or generate trading signals. And reinforcement learning allows bots to like learn optimal trading policies through trial and error and receiving rewards on like penalties or based on their actions. And this NLP, natural language processing, enables bots to analyze new articles and social media sentiment to gauge market sentiment and make informed trading decisions. And if we come to the literature review of this project, this provided data discussed from research papers on prediction and trading strategies and automated stock trading using machine learning and other reinforcement learning. These papers introduce the TDO algorithm for prediction, and this purpose on assembled strategy to trading decision and emphasize the importance of domain specific challenges and techniques. They also address the challenges like data quality and overfitting in applying reinforcement learning to algorithm trading. This article provides like the insights and the experiment evaluations and further research directions for this deep reinforcement learning in the financial domain.
Before going on to the implementation, let's discuss the four key features of the stock trading bot, which includes Q-learning algorithm, state representation, action space, and reward function. The first key feature of the bot is Q-learning algorithm. Q-learning is the fundamental algorithm in the field of reinforcement learning. This algorithm is aimed at solving Markov decision process by learning an optimal policy. Q-value function is used to estimate the expected cumulative reward. The Q-value represents the quality of an action space pair and guides the decision-making process of an agent. The Q-learning algorithm follows an iterative process known as temporal difference learning. It starts with an initialization of the Q values for all possible state action pairs. Then the agent interacts with the environment, observing the current state, selecting an action based on the exploitation trade-off, and receiving reward. The Q value for the chosen action in the current state is updated using the Bellman equation, which combines the immediate reward and the estimated value of the next state action pair. Although Q-learning is a powerful algorithm, it does have some limitations. It requires complete knowledge on the environment, which may not always be feasible in the real-world scenarios. The second key feature of the bot is state function. The state function uses a combination of the technical indicators and market data to capture relevant information about the market conditions. The specific implementation of the state function may vary depending on the dataset and trading strategy used. However, it typically involves processing historical price data and calculating various technical indicators such as moving averages, relative strength index, and volume related metrics. The state function is essential for the Q-learning algorithm to operate effectively. It enables the agent to perceive the environment and identify relevant patterns or trends that can inform its trading decisions. The third key feature of the bot is reward function. Various factors like profitability of the trades, risk management objectives, and transaction costs are taken into account for the reward function. For example, a reward function might assign positive rewards for successful trades that generates profits and negative rewards for losing trades. Additionally, it may incorporate penalties for excessive trading or deviations from risk management rules. The design of the effective reward function requires a careful consideration of the specific trading goals and constraint. It should strike a balance between providing informative feedback to the agent and ensuring the agent learns an optimal policy without getting stuck in the suboptimal behaviors. It influences the agent's behavior by providing feedback on the desirability of its actions, ultimately shaping the overall performance and effectiveness of the trading strategy. Not only these, there is another key feature that is action space. The agent can choose actions such as buying, selling, or holding a position based on the Q values learning during the training. The action space consists of a discrete set of actions that the agent can choose from, such as buying, selling, or holding positions. Moving on to the implementation, Sushanth will discuss the implementation.
Coming to the implementation of the stock trading bot, the bot will require general few key components that has to be included for the proper working of the bot. The trading bot includes components such as data ingestion, pre-processing, strategy development, order generation, execution, revision, and trend following. Coming to data ingestion, the bot requires real-time market data, including stock prices, volume of the stock, and other relevant information, which can be provided through APIs or the website. In our case, we use Yahoo Finance website that is provide us the details of the stock, that is pre-processing and featuring trading. The acquired data is pre-processed and transformed into meaningful features that can be used by the training bot. This may involve calculating technical indicators such as moving averages or other custom metrics. Strategy development. Traders define the strategy based on their objectives, risk tolerance, and market condition. The bot should be aware of the real-time market conditions for producing optimal profits. Strategies can range from simple moving crossovers or to more complex machine learning and artificial intelligence algorithms. Order generation. The bot generates buy or sell orders based on the defined strategy and market condition. It takes into account various capital, available capital, position sizing, and the risk associated with the buying or selling, and also the rules. Execution. The bot communicates with the brokerage platform or to exchange the generated order. This may involve limiting orders, market orders, and other order types with the brokerage platform. Mean revision. The strategy assumes that the price will eventually revert to their main value. Bots should identify overbought or oversold conditions and take position opposite to the prevailing trend to optimize the profits. Trend following. Bots should use this strategy to identify and write the trends in the market, the real-time market. They look for the consistent upward and the downward price movements and take positions in the same direction. Coming to the modules that have been used in building the bot are Keras, Sys, NumPy, and Math. Keras, as you know, is a deep learning library that provides high-level API for building and training neural networks. It is built over TensorFlow. Popular applications of Keras include image classification, object detection, and NLP. Sys is a built-in Python module that provides various system-specific parameters. Its application is error handling, assessing system, and memory management of the system. NumPy provides a high-dimensional array object The application of NumPy is general data analysis, data manipulation, machine learning, and artificial intelligence, and also image and video processing. Math is the Python that provides various range of mathematical functions for various numerical computations. Applications of math libraries such as scientific engineering calculation, data analysis, and statistics, and also 3D graphics and geometry. Now let us move on to the execution part. After all the required modules are installed and ready to be used, we have to run the train.py file in the directory. We also have to give the stock name, the window size, and the number of episodes as the argument, as the input argument for the bot to be run. For example, in this case, the given data set, that is GSPC 2011, the stock of GSPC in the year 2011 was downloaded from the Yahoo Finance website, and it was used to train the model. The batch window size of 1 and the batch size of episodes of 100 has been used in this case. If you can see, the bot starts to buy the stocks at various prices, that is $1,276 and so on. And it sells at one point where it thinks that the profits are high. After selling, the profit is 11. This increases so on, and it buys and sells and buys and sells, which will make a significant increase in the profits made by the bot. Coming to the code implementation, we can see this is the directory of the code: agent, data, images, models, evaluate.py, and functions.py, and train.py. The agent folder includes the guidelines set by the agent, that is the strategy development that has been done by the agent for the bot. Coming to the data, this is the data set. The stock here is GSPC of the year 2011, and this CSV file is the overall stock of GSPC. Presently, we are considering the GSPC stock of 2011 due to space constraints and the run complexity constraint. The models includes this is the folder where the training model, after it is trained, will be saved into this folder. We can see model EP0, model EP10, 20, 30, and so on till 100, which includes at the intervals of 10, the model is being compiled and saved in this specific folder. Functions.py includes the stock data value, formatting the price in the data set, calculating the sigmoid of the equation, getting the state at which the bot is currently running. This is actually the major pre-processing stuff that will be doing to the dataset file. Why is the core of this bot? It includes the reading of stock name, window size, and episode count from the system command argument. The stock is then read and the length of the stock is actually calculated. For example, in this case, the case that we have run, the stock value actually contains around 250 samples. Each of them have date, the window time, open value, highest value, lowest value, and the closing value, and also the volume of the stock. With these files, the training bot actually compares runs uh, runs the bot for buying the volume and also selling them at a optimal profits. This happens until the number of episodes mentioned. For our case, the episodes that have been mentioned is 100. So, which means that the bot actually continues the same step for 100 times until the optimal profit is made and the model is being saved for further evaluation. A total profit is initialized as 0 and the agent.inventory is an empty list. Whenever the bot buys a stock, the agent inventory will be storing the amount of stock that has been stored, and also the buying price will be stored in that. Once this bot sells the volumes, it will calculate the profit made, that is selling price minus buying price. This will be inculcated to the total profit to calculate the overall profit after selling and buying all the stocks. we can see that the total profit will be printed, that is $4.93 in this case. And so on. It will continues until another bot is buying. The episode 3 will be starting here, and it we can see that the bot will buy is buying the bot is buying the stocks at a rate of $1,271, and so on. It will sell at $1,276, which makes a profit of $4.69. So we can say that the total profit that has been done is $4.69. Once this is done, the model will be saved to the following folders for further evaluation and running it on the various other datasets. That's it. Thank you from the presentation.